Okay, we are in the final 2 days of course material, or a day and a half of course material, and what we're going to do is look at chemistry of gases. So in the last unit we looked at chemistry in solutions, so we looked at things that were aqueous or dissolved in water. Now we're going to look in gases. One of the most important laws you can know is that 1 mole of any ideal gas, now ideal gas means it's just following the laws, occupies a volume of 22.4 liters at STP. So it doesn't matter what your gas is, whether it's a big gas or like a small gas like helium. If you've got 1 mole or 6.02 times 10 to the 23 particles, it will occupy 22.4 liters. So the mystery here is, what is this STP? This is standard temperature pressure. This means at 273 Kelvin, which is 0 degrees Celsius, and 101.3 kilopascals. Now there are 3 common measurements for pressure when we're doing gases. There's ATM, so the standard there is 1 ATM. There's torrellis or torrs, 760 is the standard there. Ignore my scratchings. And 101.3 kilopascals. The only one here you're going to have to convert is degrees Celsius to Kelvin. So what is Kelvin? There is an absolute lowest temperature that's possible, and it's right about negative 273.15 degrees Celsius. At that temperature, all motion stops. And scientists have come close to that before, but they've never quite got there. But if they extrapolate a graph from the motion of any particle all the way back to when there's no motion, it ends up at that same temperature. So at 0 degrees Celsius or freezing, that would be 273 Kelvin. At boiling, that would be 373 Kelvin. If you are given temperature in Celsius, you must add it to 273. If you do not do things in Kelvin, it will not work. Here's our 3 relationships for the day. I don't get too concerned with the names. Boyle's law, Charles' law, and Gay-Lussac's law. So those are 2 scientists who worked on this law. So for Boyle's law, what it's saying, as pressure goes up, volume goes down. So whenever you have 2 variables beside each other, they act in an inverse manner. So as one goes up, one goes down. So you might be thinking, well, wait a minute, I took pressure and I put it in my bike tire and the volume went up. Now, we're not talking about pressurizing the inside of a system. We're talking about pressure from the outside. What would happen to a balloon if you put pressure on the outside of the balloon? Let's try one here. Let's work in ATMs. And it doesn't matter which of these pressures you choose. Let's choose ATMs. So let's say our pressure was 2 ATMs. And our volume was 10 liters. Once again, it doesn't matter whether it's milliliters or liters because we have volumes on both sides of the equation, which means it won't matter as long as they are the same. So if this is milliliters, this has to be milliliters. If this is liters, this has to be liters. Let's say that we increase the pressure to 4 ATMs. What's the new volume? Volume 2 would be equal to 2 ATM times 10 liters over 4 ATM. You can now cancel out your units here because they're the same. 2 times 10 is 20, divided by 4 is 5. So our new volume is 5 liters. That's just an example of how to use Boyle's law. How about Charles' law? When you have a variable one on top of the other, it means that they're going to do the same thing. As one rises, the other will rise. Let's say that we have a volume of 10 liters and we have a temperature of 300 Kelvin. Remember, it has to be in Kelvin. If they give it to you in degrees Celsius, add it to the 273. What is our new volume? I guess we can continue this as V2. If our temperature goes up to 600 K. All you do is multiply both sides by 600 K to get rid of the 600 K on that side. And what's going to happen is we are going to get 600 times 10 divided by 300. So that's going to be 6,000 divided by 300. I'm going to get rid of 2 zeros on the bottom. And so that looks like it's going to be a volume of 20 liters. Sorry folks, I'm not trying to teach a math lesson. I'm just showing you how to put things into the formula and use the formula. Gay-Lussac's law deals with pressure and temperature. Pressure and volume, volume and temperature, pressure and temperature. Once again, if one variable is above another, that means if one variable goes up, the other variable goes up. When the two variables are beside each other, as one goes up, the other goes down. I'm not going to do an example of Gay-Lussac's law because it's going to be manipulated the same way Charles' law is. The only thing I'm going to tell you is if they tell you to solve for something that's on the bottom of an equation like this, all you do is flip both sides. So it's hard to solve for a variable when it's on the bottom. So if I flip both sides, I can now solve for T2 more easily. Folks, you have 2 pages of questions to work on today. If you get the hang of it, you don't have to do all of them. As long as you know how to use these 3 laws this morning, you've got everything.